Okay, we're going to wrap up 1.1 and add some things that the book doesn't go into as much detail on. You need to know what physics is in order to study it this year. And so I added a little bit to their definition, and I've found this definition in other places, that physics is energy, matter, and how those two relate to each other. But isn't that what chemistry and biology is too? So it is really hard to separate all the sciences from each other because they're all interrelated. What we choose to put in a physics textbook tends to be a certain group of things. It also tends to be what we know from experiments in history. So we're still discovering new things in physics. And those will get added to the textbooks as they are basically agreed upon by physicists throughout the world. But what we know now is put into your physics book and used by engineers, for example, when they design new things. Okay. And then we've talked about these disciplines, but most of the big categories that are considered physics and put into your textbook are these ones. So you might want to pause so that you can include these in your notes. And then, of course, we're still discovering new things. That's what science is about. So you know you've studied the scientific process since you were little, right? So you know all about this, and we're not going to go into great detail here. But I think what's important, especially in physics, is that part of testing is developing a model of how you think something works. And often that means that you simplify it at first. If something's very complicated, you might choose to study just a part of that, or you might choose to ignore some part of that phenomenon that is too difficult to understand at this moment. So for instance, when we talked about the coronavirus, okay, if you are just trying to design a N95 mask that is going to keep spit particles out that have the coronavirus as part of the spit, okay, then you don't need to know about its DNA. All you care about is you are modeling the spit as particles that move through the air, and you don't need to know all the complexity of what the DNA sequence of the coronavirus is, or RNA, sorry. Okay, so you are simplifying it as a particle moving through the air. You might have studied, you've done this before, because I believe in biology, you studied enzymes and maybe how an enzyme works with a substrate, and it fits together like a lock and key, and that's how your body can work on, your enzymes are going to work only on a specific chemical to speed up a reaction. So you're using a lock and key model. Maybe it's more complicated than that, but for now, that's enough for you to understand and use its structure to understand its function. In this class, we are going to use math as a model of how the physical world works. So we are going to use a math equation to model, for instance, where is this bungee jumper as time goes by? She's going to go down and up and down and up and down and up, and we might choose to ignore the fact that there's some air resistance that's going to eventually mean that she doesn't go down as far or up as far. and she comes to rest. Okay. This is a slide that's a little confusing at first, right? Like these three things. This is a model of a building, a very fancy sort of, this is maybe an art museum or something. This is a model who is modeling a dress, okay? And then this is a math model of a physics phenomenon. Like how far something moves if you know where it started, how fast it was going to begin with, and its acceleration, and how much time has gone by. So all of these are models, okay? But this is a model that helps you predict what a building is going to look like once it's finally built, before actually building it, because it's expensive to build. This model is going to help you predict what this dress would look like on a human being. Maybe, that whole sense of models has gotten twisted because now we don't have models that look like normal human beings, but okay. And then this math model is also helping make a prediction of where something's going to be with a math function. Okay, I'll skip this over, but you should watch it sometime. Maybe we'll watch it in class, or you can see the slides on my DSHA to go click that link. Okay. And then there are also rules that scientists tend to call a law, but that has a different meaning in science than it does in like government. So a law is just a pattern of nature. For instance, Newton's first law, which you would have studied in middle school. So they are a pattern, but they don't include an explanation of that phenomenon. And then different from that, we have a scientific theory, which tends to explain what's going on. And a theory, even though it sounds like it might be still proven wrong, which it could be, it doesn't rise to that level unless a lot of experiments have come to back that up. So one theory here from chemistry is the Vesper theory, and that explains why the molecules arrange themselves like in that pattern that they do. So you learned that in chemistry. That was a legit explanation of why those molecules have their electrons in certain places. The theory of relativity in physics was developed by Einstein, and it actually helps explain why satellites tend to have time differences between where they are located and where down here on Earth we see time differences. So we would not be calling it a theory unless we had a lot of evidence to back up that explanation. Okay. And they tend to be very broad and include a lot of information and observations. They can sometimes explain why a law is showing what it's showing. Okay. Now, just like a hypothesis, though, all of these can be disproven. So hypotheses, models, laws, and theories can all be proven incorrect, or parts of them can be. We want to say, oops, that part we found out not correct, so we're going to revise that. Can they ever be proven? No. So we can never prove something correct, which is maybe seems kind of frustrating, right? You might spend your whole life trying to back up some idea that you have. But you can't see into the future. So you can't ever show for all time that this idea is correct. So we're going to hold judgment because we don't have all the answers for every question that could be asked about that topic. Okay, so then try connecting all these concepts, laws, theories, models, hypotheses in a concept map to see if you really understand the connections between them.